Okay, let's go ahead and get started here. Well, hello, and welcome back. So, good news from last time was, while I prepare my drink here, that we did get the situation figured out with producing a key that worked. Signing and verifying, producing a key from a seed, signing and verifying. So we got that done. I don't think we're actually generating the key per spec because I have to double check. I don't think we did actually add the salt to the key generation. Not that it matters. It could matter in terms of, making sure that the RNG, the random generation, is being followed precisely. But anyway, not the RNG. That if we wanted to create pseudo-random keys or testable keys, I don't know. Never mind. Point being, there is importing and exporting the private key is not a problem. Generating the key from a seed, a seed for the random generator, we may need to add a specific. I don't know if it was a specific salt. I think it might have been a specific salt. Anyway. Whoa, no! Hold on. You overboard. Okay. There we go. Okay. Now the challenge is... I want to get the version that we've created to pass the tests, just so I can feel good about it. In theory, that's just a matter of adoption. Or adapting. Okay. Okay, so if we want to pass the we want to pass the tests, then we need to go into crypto BLS bls.go. Oh, I think we should we maybe should just make a different version here. Oops. All right. And we're going to open up each of these in turn, and we're just going to change the package name to Go BLS. And in the meantime, things are going to complain because the package name is wrong. Okay. And then... oh, bother. All right. So I think all I got to do is replace stuff in this folder. Instead of using the Go bindings, I'll create a different BLS package that has the same signature. Okay. Oh, no, in Go, we always do type in front, except sometimes, right? Alright, so far so good. Basic scheme MPL. Alright, cool. So far so good. Private key from bytes. Private key from bytes. Private key from bytes. G1 element. Okay, and the schema does take the Cinema Bob. Okay, yeah. Alright, private key. Priv key. Wait. Private key from bytes. Oh, okay. I see what we're doing here. Alright. Alright, so it's just whatever its internal type is. So this, yeah, this. Alright, so that shouldn't make any problems. Okay, G1 element, though. That scares me. That's internal implementation details if I ever saw it. Public key shares. G1 element from bytes. Public key share. What's the purpose of this? Threshold public key recover. Recover threshold public key from public keys. We'll have to check on that one. I'll see if there's a threshold where we're at. Okay, so that one's a little more involved. It's, yeah, okay. Threshold signature. So the recover and then the hash. Okay. G1 element from bytes, G2 element from bytes. I'm a little bit confused about this because this just seems like internal implementation details. This may not actually be necessary at all because, see, for verify here, it's getting, I mean, basically this is just saying get public key, get signature. So I guess a G1 element. Yeah, we saw this before. So a G1 element is a public key. Like a G1 point is a public key, a G2 element is a signature. I think we saw it differently though. Didn't we see the reverse? Could have sworn it was the exact opposite. But, or whatever. Okay. All right, so that, I think this is internal implementation details that we can actually just ditch. Because we can just get we just need the bytes to be converted. It doesn't, I don't think it really matters whether we're classifying it as a G1 element or G2 element, as long as the bytes are right and they go into the function here. So this is where the schema thing, it would be better if it just had a function verify bytes that did its own internal, because yeah, this is just a leaky abstraction. We're just getting internal implementation details that we shouldn't have to get. All right, and is that the same thing here? So verify signature. Okay, so is that all of that stuff? And then private key from bytes. Sign. The passing in the signature again. Okay, so we should just change the signature of sign and verify to be bytes, or provide a sign and verify bytes function, so that the internal implementation details shouldn't have to be exposed like this in the first place. Let me think. When I did my equals, did that? No, I didn't. So the recover threshold thingamabob, what does that actually do? BLS threshold public key recover. Okay, yeah. So it's just kind of some wrapper around stuff that seems like it should have been exposed in the first place. So I'm actually not thinking that there's much of a story here. All right, let's... I would have avoid pointer. There we go. All right. Now let me go figure out, do we have a recover function in that wait, why am I? There we go. Dang it. All right, so we might not be able to get all the tests to pass. Might have to just delete some tests for now. The recover function, we may need to go about a different way later. Darn. Okay. Another thing I want to do before I go too far with this, let me go back to check out that Ethereum library. Now that I feel like I've got a handle on all of this. Let's see here. I'm just gonna clone it locally so I can do faster search on this. Holy moly, that's a lot of stuff. What in the world is in here? Oh, that's weird. Uh-oh. Uh-oh, GPL alert. Alright. So, what I'm looking for is obviously not there. It doesn't look like this is ever used. I'm so confused. What is the point of this? It's used in test, but it's... Is this real? I'm just so confused. It's like it's used for required gas. That's it. That's the only thing it's ever used for. Require gas, run. 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 Require gas. That seems so strange to me. I mean, was there not... I thought I could have sworn there was a sign function. Was there not? Wasn't there a sign function? Oh, that's frustrating. Then what the heck is this thing even good for? Does it expose the same functions as the whatchamadoodle? Let's just try this out. Okay, so we'll go to the... We'll do a little bit of bad stuff. Don't tell anybody. Okay. Killick. So we're just going to do a straight up string replacement. Whoops. Maybe he's getting slow. We're going to speed it up. There we go. Okay. See if it builds. Oh, darn it. All right, too compressed. Okay, so apparently Ethereum doesn't use the compressed form. So, all right, so the Ethereum thing's a bust. All right, so but the cryptology one, which, okay, let's just go back. I believe that this one had been audited. Audit reports. Okay, here we go. Okay, so what commit message was this in? I wish they would just like give you the actual date. There we go. January 21st, 2022. Okay, and then what are these from? September? Interesting. So we have the audit reports. Let's take a look at these. Are these from the audit reports? Oh, when I first heard the news, I thought that the toilet was flooding. And I was freaked out because there's a part of the floor in the bathroom that isn't caulked properly. And then water would just go into the ceiling. That would be so terrible. But no, that's not what happened. But I need to go ahead and caulk that so that if the toilet ever does flood. Anyway, just misunderstanding. There was the water was running from the toilet, but that's as long as the toilet's not clogged, it's not a problem, because every drip of water that leaks from the toilet is just one of the mechanisms wasn't the button needed to be pressed. So there was water was slowly leaking into the toilet bowl, but then that every drop that goes in the toilet bowl, because the weight of the water causes the water to go down. So if you add one drop, then that will raise the water level, which will then the weight of itself will cause it to go down. When you flush the toilet, you put a lot of water in, and the water goes around the bowl, and so it's that at that point it's the suction of the moving water causes it to drain completely. But if you were to just take a water hose and stick it in your toilet and turn it on, and it wasn't on too much, you know, it's just dripping, every drop will push it down. There's a little S pipe thing. Anyway, so it's freaked out at first, but it's all right. Okay, so what I want to know is, with the audit report that was published, okay, it looks like the fixes came in before the audit report was published, but I'm not sure. Because it would make sense that you would fix and then publish the audit report. It doesn't make sense that we'd publish the audit report that has a bunch of vulnerabilities in it and then not fix them. That doesn't make sense. I mean, this was abandoned later that year. So let's see if we can find any issue here about the audit. Because yeah, I mean, if I can, now that I've created something that works, I'd prefer to have the stuff that's audited be used. Yeah, it stinks. Okay. I wish they had not closed out the repository, or, frozen it like this. I mean, I guess I could go check those things and see. I don't see anything about recovering a threshold here. I wonder what VT stands for. I'll ask GPT that. It may know. It's often pretty good at that sort of thing. What does VT mean in this context? Verifiable threshold? Maybe. Okay. So the recover stuff, I don't have an immediate solution for. Okay, I just want to get back. Why did they make it so hard? I just, like, can I just get back to the repository? Can we, is that possible? There we go. All right. And it said that it was compatible. Okay. Alright. That was my update on that. Let's see if any of these have a threshold thing. That does not have threshold. Does it have recover? Nope. Nope. Okay, but it does have a recover. Nope. Okay. That's all we got. All right, so with that, I know that I will not be passing those tests tonight, and probably not ever. So let's just go ahead and move on then. I can check that things pass the other test, but now I'm actually kind of concerned. I mean, I don't know. Tomato, potato. We have an audit report. We know what needs to be fixed. If we have to fix it, we can go through, we can check and see. Yeah, and I am confused because the kill it code was used for Ethereum, but Ethereum dropped the dead code, which is a good thing to do. But now the only implementations that we have are not audited. So we probably want to hire, if we're going to take this further, we would probably want to hire that security firm that's familiar with this in Go to do the audit of the other code. Well, I don't know. We could probably start with the code. If we needed to do it, we'd probably start with the code that's been audited and work through the findings to make sure things have been fixed. And there's probably a fork that we could search through and find. If those things weren't fixed, we could probably find a fork that has a bunch of those fixes. It's just who has the version with the audits and the fixes. That's the question. All right, but okay. We're going to get out of here. All right. Okay, and there's definitely you know, a key from bytes type of thing. Yeah, I don't necessarily like stuff that's super chainy like this. This is kind of hard to. I mean, it's terse math, so it's hard anyway. But I think it's harder than it needs to be with all this, you know, key dot value dot bytes from bytes da 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 da. Crap. Okay, this is where the salt is. And this, okay, so this did work. Ah, because the seed was the same that had the checksum on it. This has the salt. Okay, good. Crap. See, this is kind of hard to read. Let's just, for the sake of me being able to grok this a little better, let's just move a few things around here. Okay. Pin 0, extract, expand. OKM. Alright, key derivation function. OKM. Why is it OKM? What might OKM stand for? Let me GPT this. I don't know if that's a thing. Output keying material? Is that a thing? Okay. It's just... Oh, no, there it is. Output keying material. All right, GPT. All right. Oh, wait, there's key from bytes. Why didn't I see that before? Okay, but look at these two. They're different. Okay. All right, so we do have a key from bytes. That's good because I would have, from what I was reading there, I probably would have implemented wrong. Although it wouldn't have mattered. Well, I mean, okay. So if that were correct, then if you were to just mod it again, you should get the same result, right? Does that follow or does that not follow? Like, I mean, just sanity check here. If I did this mod smaller number that, okay, and then if I did this mod that, I'm going to get the same result. Yeah, okay. So it's just making sure it fits into a space. And then once it fits into the space, I mean, you just mod it every time. In fact, that's what I would do. Just to make sure you don't get something weird. Okay. All right, so let's go back in and we're looking at the test. or what we're going to be able to test, rather. And so we're looking at the sign function, and we just want to make sure that what we provide is essentially a compatible sign function. So this function should be able to use that function. All right. All right, that comment right there is exactly what I was suggesting. We're not going to do that right now. I mean, I could put a to do. Yo, what's up, Artem? Artem? Which way do we go with that? Okay, so this one is going to be then BLS core.private key or something. All right, there we go. So I got that one out of the way. Okay. I gotta figure out where my Keemadoodle went. Was it... Okay, it was in here. Key from Bytes. Ah, crap. Okay. This is going to be on... Alright, now I need to go check on that. Ah! BLS private key and a message. So now we've got Chia BLS. Ah, bless me. All right, we're doing some no-nos here, by the way, folks. We're violating encapsulation boundaries. Okay, I'm a little confused here. Golang mod big int. This seems like unusual behavior. Okay, take me to the docs. There we go. That's what I wanted. Okay. All right, so here's mod. That just seems so strange to me. It just doesn't seem very Go-ish. It seems like there would be a mod operation. Oh, I think I see why they did it, because they didn't want to nest the packages too deeply. So they didn't want to have like a big ant, big float, big bub 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 bub. They didn't want to broaden it too much. And they didn't want to have too much depth. So they just attach it to integer. And then since it's going to have to create new memory space anyway because of the arbitrary width, is it okay? We'll allocate where you want it to go, and then we'll return it. We'll put it in that allocation rather than return it. I kind of get it. I would love to hear a talk or read a blog post as to why they made that choice to help me kind of drink that Kool-Aid a little stronger, because this doesn't feel right. Okay. Okay. Okay, and then I need to get that signature as bytes again, too. So let me go check on how I was doing that already here. Does the signature just come out as bytes? Scheme sign. Yeah, it just comes out as bytes. So... By the way, it is generally considered ungoish to name your variables after their type. However, in this context, because the type is so screwy, I do it. This is really high context stuff. And high context stuff is bad. So wherever we can, we want to work around that. Oh crap. Hold on. Uh sign. Sign. What the letter L? Okay, so we got a problem here that looks like it exists in the original code where sign and sign digest are not doing what they should. Now, this may just be... I mean, maybe that's the only difference. Could not determine package name. What are you talking about? Go BLS. What? Go BLS. All right. That's weird. I don't think that test needs to be in there. That's even in the wrong package. Test reverse should... Yeah. That should be in its own special place. Kind of a weird place for that to go. Dang it! I thought there was a bunch of tests here, but really there's kind of not. All right. Oh, whoops. Did I modify the wrong? I did. Okay, no wonder. No wonder it's griping at me. Yeah, as far as I could tell, these are duplicates of each other. Hash byte, sig byte, pub key. And then pub key, according to this, is just bytes, right? Yeah, okay. So pub key here is just bytes. Okay, verify signature. Got it. Yep. So sign digest and sign are only different in the function that they are in the sorry. Okay, so I'm pretty sure they do not differ in terms of bytes. I'm just going to go check this on the other one. They don't actually differ in terms of bytes or what's actually being done. So okay, let's restore this one. So if I were to take these bytes, or sorry, what I mean is the code. When I say the bytes, I mean the characters of the code. Oh, whoops. Nope, that's not the right thing at all. All right. Yeah, these are the same function. They're just called with a different name for semantics. Yeah, look, see? Exact same function. Okay. Yeah, that could and should be clarified. I think I bumped the I noticed this earlier, but I think I bumped the camera and it put the I guess I've only been showing my nose for half of this thing. Yeah, earlier in the day I bumped the camera and I knocked it over a little bit. So be it. Okay, so those are not different, so that makes me happy. And then I mean, literally what this ought to do is just call sign, just so it's more clear. There we go. It is documentation only, semantic only. All right. So I don't need to worry about that. All of that checking the private key. Okay, pub key. Okay. So we're just going to be calling. What's it going to be? Interesting. Okay, I kind of see what it's doing here. That is kind of valuable information. All right, so I'm gonna have assign bytes. I'm gonna have verify bytes. Get public key? What nonsense is this? And setters and go? It's just public key. Dang it. All right, private key from bytes. You know what? This is stupid abstraction. We're just going to get rid of this. See. Where'd that S come from? Oh. Okay. That's weird. Interesting. All right. All right, type, proof key. All right. That's right. All right, there we go. Oh, we're getting so mix and matchy here. Right. Value right there. And value is a pointer to a big int. So what's the problem here? And that returns a pointer, right? That's a pointer, returns a pointer. Okay. So there we go with that one. Okay, so in order to be pubkey.crypto, this thing has to have, I think it's an equal method. Missing method address. Oh. Oh. Okay. Well, let's go look at that then. Gotta wrap it. Right. All right. Unknode field value. Oh, because it's lowercase. So I have to, whoops, I have to find out. Okay. So we just have to run, we still have to run from bytes, key from bytes. Right. Okay. No big deal. So we do the wrapping ahead of time. Okay, so where are we at now? Right. Okay. Send bytes? No? BLS basic. Sign. Yeah. Oh. Has to be scheme or schema? Will they make schema? Schema. I don't think that's correct, but whatever, we'll go with it. Okay. So now that's working. Let's see what we can get to here. Is this done now? I don't think the keygen is ever different. Oops. I think, you know, the whole Secret to seed. Oh, okay. All right. Anything else? All right. Verify. And this should just be returning verify signature. Okay. Let me just make this small so I can read more of it. Just want to make sure the only thing different between these two is a variable name. Okay, all right. Okay, so that's as expected. And then this one. Now, this is interesting because the pub key actually does not specify the schema used. So here's our little verify function. So we probably need like some sort of pub key from bytes. It's used for tests. Okay, hopefully this isn't all in vain. So I was just told that these functions are only used for tests, which seems kind of like well, I guess it's I'm forgetting the word right now. But that, I mean, that wouldn't make sense. We create code to test it, but what? All right, public key, that is bytes. All right, so we do have a potential problem here, which is that I don't know. Eh. All right, so in here, yeah, I don't think that we actually have any place where, let's see. Get public key. G1 generator. I think we need to go look at public key value. Okay, so this is a point G1. Oh no. Wait, from compressed data. That is bytes. Okay, so new public key is from bytes. All right, we're good there. Okay, cool. Crisis averted. Okay. I might actually want to go back to wherever I decided to make that an ampersand type of thing and not make it an ampersand type of thing. Alright, so with a little luck, and it seems like the key signature stuff could be re-implemented. Yeah, there's... man. There's a number of things here that would be nice to get. This is... There is more novel work here to be done than I expected. The whole suite. Let's see what BLS G1 element from bytes. Okay, so this could be re-implemented. I'm not going to re-implement it right now, but I believe that this could be re-implemented based on what we already have. Well, I'm a little confused about this one, though. I'd have to go look into that. So there might be novel work to be done for the threshold public key recover and threshold signature recover. You know, but at this point, I think it's doable. There's enough stuff. I'm not going to do it. That's not where my focus is. I'm just saying, at this point, let's see. Is this even used? as far as I can tell, it's never actually used. Let's just double check on that. What's up, Kiwi? Yeah, I don't know what I'm doing either. So that makes two of us. Alright, validator set. Oh, so for the chain lock is what we need the recover threshold from public keys for? Okay. Alright, so that is important. So that would actually... Oh my. Wait. How does this... Where did that bubble come from? What was that? Was that you hitting the thumbs up on YouTube or something? I don't know what plugin did that. I'm not sure at what layer that was happening. But thanks. Okay, recover threshold. Alright, so that would require novel work. That, as far as I can tell, that's never been implemented in Go. And then there's other novel work to be done, which is probably to go through the Go Ethereum mentions of Killick and make sure that the PRs that were sent to Killick have been addressed. And just based on my own findings of seeing somebody complaining about a PR with, I think anything in a cryptography library, ultimately, any sort of mishap other than a null reference would be a security vulnerability. In Go, null references are not security vulnerabilities because Go handles memory safely. But any time it's possible for a zero value to go through, or verification to pass because something was zero, or the identity value or function or whatever, or you can get something to go through with a different scheme. So that stuff would be, yeah, there's things that need to be checked. I would probably not want this chwut as a dependency. I would probably want to refactor it and bring it into Dash Hive. Because, well, I guess it depends on... what was I saying? All right, well, let's test and see if these tests pass. What tests are there? Do they pass? All right, cool. So I don't know how big of a win that ended up being, though. I think that this had more value in just matching the signature than it did in the test, because look how pitiful the tests are. I mean, it... T-run, sprint... I mean, I guess it just is kind of doing a loopback test that we can take these values as base 64, we can import them, and then we can derive the public key, and then we can see that the bytes match in both cases. I mean, that's good, right? And then we can take a secret and we can generate the public key from the secret with the seed and the salt, and then we can end up with the same public key. So the tests, they kind of suck in that they don't mean much. Also, this is weird. Random bytes. So this says message, but it should say digest. So, you know, it's like a faux hash. So that's what this should be. All right. I'm very confused. Why is that saying undefined priv key? Oh. Okay. So how did the test... What? I'm a little confused about this. Oh. Oh, right. Okay. Okay, because you have to test the package as a whole. Duh. You can't test a single file because you'd have to test the multiple files. Because if you only test a single file, then the things aren't defined because they're not defined necessarily in that file. Alright. So what about the benchmark stuff? Do we get like a go-v. Go test-v. I want verbose. Okay. BLS basic, internal, and crypto. That's what I'm going to bring over. And then I'm going to call this a night. Internal. Crypto. Basic BLS. Anyway, I didn't finish my thought from earlier entirely. I guess I'm still kind of, noodling around in my head. Oh, BLS basic. But I don't think it's... I'll say this. There is work that needs to be done here. There is a library that needs to be completed. There's more work that needs to be done before the relic could be ripped out. And I don't think that there's enough. I am concerned that it does not appear that we have a complete Go library that's been audited. All right. Right, that's too much. That's too much. That's too much. There we go. Still not finishing my thought. But... Let's see. Okay, that's fine. It's fine that the build failed. Okay, cool. What's up, DJ? All right, here we go. We'll test all the things. Okay, go test bench. Let's try that one too. All right. See what the benchmarks look like. Whoa! Is that really? That much better, huh? Wow. Yeah. Pretty cool. Interesting. Yeah. Interesting. I mean, it also could be, simple one check, throwing it off. And then the signing. And I mean, I didn't even do it optimal, right? It's making more byte copies than it needs to. So if not, so anyway, the point that this goes to show is that there wouldn't be anything really lost by switching to a pure Go implementation, and if we wanted to tweak that to get it to be faster, we certainly could. I actually don't even know what these numbers mean. So not only is it more secure, easier to read, memory, it's also faster. Now, you know, some of that security, like I said, just me casually browsing the source code, I came across potentially significant security vulnerability where it was returning. I don't know what it would have returned if it did the work. I guess that's the thing that we'd have to check, right? Is the default return value false, or is the default return value true? If the sizes of the slices were different and the number of messages were bigger, then it could go through and could pass. I don't think that in practice the way that it would get used would, I don't think that code path would end up getting executed. The other thing that we have was if the key, if the thing that was passed in was 0. So let's say we passed in 0 keys somehow, we get tricked it to pass in 0 keys, and then we gave it 5 messages, could potentially verify those messages as true. So I don't know. I don't know if that's, you know, it was a logical error. Is it a security error? Maybe it is, maybe it isn't. To what degree does some other software get to decide, you know, what goes on there? I don't know. Anyway, so this is all good stuff. I did want to run TinyGo. Hold on. That was one thing I did want to run here. All right, so let's run TinyGo. TinyGo run command. Fingers crossed. Now this actually is CGO, by the way. It goes through LLVM and all of that. But the important thing, oh no. Oh, is it because it goes down to assembly? Hmm. It's got FP fallback. Undefined symbol. So it's got these fallback files, right? So what if I just remove the assembly? All right, maybe I could try generic as well. Okay, so the tag should be generic. Hello! I'm just going to throw that in the README real quick. Now let's just try this out. All right, so let's take a look at this real quick. So there's the Go build, 2.5 megabytes. Now watch this. It's coming. Booyah! And then XZ that sucker, and what do you get? Booyah! Cool. So, what this means is that we can deliver, this kind of means two things, actually. So, we could deliver a WASM build of this, which is, well, when it goes over the wire, let's see, hold on XZ. Well, first of all, we could just deliver a build of this via Webby that's 106 kilobytes. Freaking awesome. So I'm not sure what all the targets for Tiny Go are. It's not going to be the performance build because it doesn't have the assembly, but it, if you just need something to ship with a script to be able to generate, to do the stuff, that's a pretty dang good size. I mean, it's not phenomenal. But, compared to 2.5 megabytes, this is something palatable. This is something that doesn't feel so invasive. All right. And if you're looking at it over the wire. So yeah, and so this is what it would be essentially if it was, I don't know how you build down to WASM. Let me just see here. Tiny Go WASM. Target WASI. All right, let's try that. I would be interested just to see what this looks like with the regular Go build as well. Then I'm popping off for the night. Gosh, that's taking a long time. I don't know what WASM opt is. You gotta have Rust. That's hilarious. Okay, cargo install WASM opt. My Rust is probably way out of date. This is probably going to take 6 million years. I've only got an M2 Studio Max Pro. I can't run Rust on this thing. I don't have a data center at my disposal. It's not a supercomputer. How am I going to compile Rust? If only I could throw a cool $30,000 at AWS, this would have been compiled by now. You know what I'm saying? You know what I'm saying? Oh, got my system to a crawl here. Right. Let's just see what it looks like. I don't know if it'll be super small. Oh, holy moly. Holy moly, that's big. Okay, so holy moly, that's big. All right, so maybe not a WASM target after all. Maybe not. But just out of curiosity, let's try to do the Go build with a target WASI. Oh. What is it? Hold on. Go targets. JS WASM. I'm a WASI P1. Is that what we're doing? So is it Go? Okay, hold on. Go S equals WASI P1. Go Arch equals WASM. Let's see what that looks like. Yeah, so Tiny Go shaves a lot off, but it's just not a good target. Not a good target for WASM. Let's just try, what was our other option? Was Go S equals JS. I think that's going to turn out really bad. Oh, okay. So it is actually... Alright. Yeah, not much difference there. Okay, I'm not really sure what that means, but all right. This is yeah, this copies. Whoa, is that my favorite tardigrade? Hey, what's up? I'm just about to get off. I've been working on... Well, there was a few goals here. Some were met, and some need to be reevaluated before continuing. But one of them was just to get some pure Go implementations of a few BLS functions that match known good functions. And I probably want to break some of that out actually into into a different commit. And the further goal would be to actually have a fork of Tenderdash that doesn't require any C or C++ code, that just works in Go as the good Lord intended. No! Dang it! Oh, good. Whew. Hold on just one second. There we go. There we go. Okay. Well, it's the wrong screen. Okay. Sounds interesting. Wish I knew more about those. No, you don't. No, this is not interesting stuff. Well, then again, I guess I shouldn't tell you what you should or shouldn't find interesting, but this is not interesting stuff. Is your data center live online? Yeah, it is. The three of us that started it are the only ones that are using it right now, because we still haven't had just various circumstances and stuff. We haven't gotten it live. I mean, we have gotten it live. We haven't gotten payments. We haven't gotten an API or payments in place. Let's see. All right, my brain's fried. Yeah, there needs to be discussion before we do anything more with this, but what we can do is we can automate the Evo node process with a BLS tool of our own make that is standalone, that anybody can compile and build, that can be done. Oh, there's that bubble again. Where is that bubble coming from? I will look at this deal on Amazon, apparently. So that looks like a pretty good price. Yeah, that looks like that's a good price for the specs. But the question, but here are the potential problems with this. So if you wanted to use this as a server, does this come with a remote access license from HP? Do these even have remote access licenses? So that's something that's critical. Like, above all else, it's not about the specs, it's about rack mounting. You can't, I mean, you could get this and put it in a cabinet in a data center, but so you have to keep in mind, you have to buy at least 3 servers. That's if you don't have a spare. So if you're going to have a spare, then you need to have 4 servers. Plus, if you want a dedicated server for backups, that's 5 servers. Now, that 5th one could be a different type of server. They need to fit in racks. They need to have 10 gig networking, or gig networking is probably fine for a lot of applications. You're going to have a clustered file system. You have to have 3 times as much storage as you want to be able to use, because when you do a cluster file system, everything's saved in triplicate. So you look at this, and yes, to me, compared to what we paid for our servers, our rack mount servers, and how powerful they are, this is way more powerful than our rack mount servers that we have. This is and the price, and it's a better price. So that's pretty good, right? But with that, let's see, do we get remote access with that thing? And we're talking remote access down at the BIOS level. So it's not remote access through Windows, it's remote, it's like a special chip that's on the motherboard. And I don't think that's what this is. I think that's something else. What does HP call their remote access? I think they've got a pretty similar name for it. Anyway, so and there's like a bunch of things. If you're just looking at the specs, it's kind of like, you know, Apple versus PC. You know, if you're just looking at the specs, it's like, oh yeah, the PC is way better. But if you have to consider the integrations, how you're actually going to use it, you know, the Apple ends up being better unless it's gaming, right? So, yeah. Anyway. I got that note posted. Okay, so the takeaway here is we can make our little tool. We can automate the BLS signature stuff. I mean, we could have done that kind of a while back, but I wanted to see kind of how far I could take this with the low-hanging fruit before hitting the wall. And I feel like I've hit the wall. Where the wall is, if we wanted to continue to go forward with this, we would have to figure out some way of doing security audits. We would need to probably not use the Chut library itself, but probably we'd want to adapt that code between the cryptology and the Ethereum code bases. We know that cryptology was audited. We know that the Ethereum code base has been audited. So we'd basically want to use all the functions that have been audited. We'd want to use those functions and then make a note, an audit note of, okay, these are the functions that have been audited, and these are the functions that haven't been audited. And these, you know, looking at the audit notes, here are the concerns we've addressed. I mean, that would be very, very formal. Another way that we could approach this is if we just, well, it's hard to say. It's hard to say with, we would look at cryptology's tests and see what things they're actually testing for, because I think they're just testing for compatibility, which is different than testing for security. But anyway, we would need to, okay, let's kick that can a little bit further down the road. We would need to implement the recover key, and it looks like we found something that might be the implementation of that, because I saw recover signature and recover key. That was in this issue here. So when we look at this, we have recover a public key, and we have recover a signature. Now, but that, unfortunately, look at that. That's actually implemented in C code. So we'd have to port C code to get that. That's the end of that. We would port C code. So yeah, this other than that, we may use Go Releaser to publish a version that can be used for automation purposes, automating master nodes and Evo nodes. I'm not even going to say that other word anymore. I hate it so much. Evo nodes. I'm just going to pretend Evo nodes and lesser Evo nodes, non-Evo nodes. Maybe anyway. We can use it for the automation and have a standalone tool for it. That's as far as we go here. I got to circle back around. Anyway, I'm gonna chat with Ryan and see where he wants to go from here, because this is very much a discovery process. You know, how far can we get? I mean, there is an actual deliverable. I haven't created the binary deliverable because I was more focused on the discovery process bits right now. But anyway, we can get there. So with that, I'll answer a couple more of the things in the chat, and then I will bounce. Yeah. So the Neverworld. With hosting, you can get a cabinet at a data center that is a non-rack mount cabinet. You can get a cabinet, like, well, I guess it can be rack mount. You can just put your stuff in there. You might have to pay extra or different, because the thing about the rack mounts is they have the sizes, they're standard sizes, and they get blocked off. And they get blocked off so that the airflow can be really, really good. So I'm going to check out your link again, just real quick. And let's see if this is mountable, because it doesn't look like it. To me, this doesn't look mountable at all. But there could be a mount kit for it. Let's see, does it say anything about mounts? And, people adapt mounting kits, but yeah, at the end of the day, this doesn't look like it's the right form factor for putting in a data center cabinet. But if you did put it in a data center cabinet, and wow, look, there's another one that's pretty similar. Yeah, this looks great. If you wanted to do a home lab where you're not constrained to form factor, then I mean, this could be it seems like a daggone good deal, right? It looks like it's for professional work, maybe like maybe somebody who's doing rendering of engineering models. Hence, it has these display ports. But anyway, yeah. So look, yeah, I agree. It looks like a great deal. But if you wanted to put it in, and the reason you use the data center is your home internet invariably is just not reliable, right? Like my home internet's not reliable, in the level that you'd want a server service to be reliable. You just got to put it in a data center for that. And then also the power at my house is not reliable in the way that I'd want server power to be reliable. You want a data center for that. When you put your stuff in the data center, you don't have to worry about all those things, because the data center has redundant power, and you can even have double redundant power, because the power already is going to be, and they're going to have redundant internet. So they're going to have more than one backbone that their routing tables are pushed to. So there's a lot of stuff when you have a data center. They're going to have the biometric scan, the two-factor authentication with the password and the fingerprint or eye scan. So you get to check a lot of boxes when you use a data center. And I mean, when everything that companies that are cloud companies tout about the cloud, like most of them are just things that you get when you put a server in a data center, right? They're not, a lot of them, the proprietary stuff is what the cloud providers actually add in value or subtract in value, depending on how you look at it. But the standard stuff is just part of the data center. Can you rent an office and pay for business internet? Yeah, you can, but it's not going to be as good. Like it's going to cost you more to rent an office and get a business internet than it is to co-locate. So you want to, getting business office space, are you going to be able to get that for less than $500? I don't think so. And it's not going to be as reliable because your power is not going to be reliable at a business office. Power is occasionally going to go out, just like it does with the rest of the city when there's a big snowstorm or a big heat wave or whatever, right? You're not going to have sufficient cooling. Well, I mean, you probably will when you're just talking about a couple of servers, 3 or 4 or whatever. But like cooling will be a challenge because if you have a data closet, that data closet will get hot. So you would want cooling. And if the thing's out in open air, they could be loud or obtrusive or whatever. And then again, your internet connection at the office, it's going to go down. When the city is doing work on the street and they accidentally cut the internet, or your ISP is still Comcast, right? I mean, you don't really have any options. But at a data center, they do have options. Like, they are connecting to multiple backbones. So it's just, yeah, it totally makes sense to pay for space at a data center when you're considering doing server stuff. Unless the uptime doesn't matter and the redundancy doesn't matter. But then that's kind of home lab. You just run a home lab. Anyway, I gotta go. Have a good one. I'll catch you later. Thank you for having the chat with me, and I'll catch you later. Adios.